Here are your video notes for lesson 8.1, graphing linear equations. And the first stuff we will look at will center around light traveling faster than sound. And that's why you see lightning before you hear thunder. And the linear equation d equals 0.2 times s expresses the approximate distance in miles of a thunderstorm given the number of seconds s between the lightning flash and the thunder. We're going to graph the equation d equals 0.2s and determine whether it is linear or not. First thing you need to do is take the time in seconds 0, substitute it into the equation. We'd get that d equals 0.2 times 0, which equals 0. We can fill our table in. We would keep doing this and keep showing that 0.2 times 2 now equals 0.4, and we'd keep doing it. Get the next value is 0.8. If we put the 10 in, 0.2 times 10 is 2. And if we put the 15 in, 0.2 times 15 gives us 3. There we have stuff. Now when we go to graph this, in this situation, distance depends on the time. So blank will go on the y-axis and blank goes on the x-axis. That would be that the distance, which is the dependent variable, goes on the y-axis and time goes on the x-axis. Now as we try to decide what should we use for a scale for our axes, notice that our seconds goes from 0 to 15, so we need it to go from at least a 0 up to at least 15. And if we number by 2's, we would get that. For our distance, we need to look at and realize it needs to go from 0 up to 3, so we probably can space this out and have it go 0, 1/2, 1, 1.5, 2, 2.5, 3. Now if we plot our points, 0, 0 goes there, 0, -4 goes there, 4.8 would go there, 10, 2 will be plotted out there, and 15, 3 gets plotted out there. Now a blank is an equation whose solutions fall on a line on the coordinate grid. That would be a linear equation. Please get that filled in your notes. All solutions of a particular linear equation fall on the line. So what does this actually mean? It means that if we drew a line, all the dots should fall exactly on that straight line. They do. Not only that, all solutions of a particular linear equation fall on the line. They do. And all of the points on the line are solutions. What does this mean? This means that if we wanted to pick another point on the line, that's also a solution. And we could keep doing this and build more and more points. There's infinitely many points on that line. And since the arrow's on the end of that line goes on forever, and the points would go on forever as well. If we pay attention now to this point right here, that point is located at 5 for the number of seconds and 1 for the distance. That would be the coordinate point 5, 1. If we put the 1 into the equation for our number of seconds, we would get that the distance equals 0.2 times 5, and if we multiply that we get 1, which gives us our y-coordinate of the ordered pair. The other thing we need to talk to you about is a rate of change. That is the ratio that compares the amount of change in a dependent variable to an amount of change in an independent variable. Rate of change will be equal to, please write this on the line in your notes across the top, change in dependent variable, and on the bottom is change in independent variable. If we take a look at the table that we had from the other side of the paper, the change in s, which is our independent variable here, is 2, while the change in our distance is 0.4. If we write that as a ratio, putting the independent variables change on top and the independent variables change on bottom, we would get 0.4 over 2. If we keep looking through the table, the next point that we have goes up 2 for s and goes up 0.4 again for 8, which would give us the same ratio. If we go farther, we get 6 for that change there, and the change there is plus 1.2. I have an extra decimal there. That is 1.2 over 6. If we check out the change here, we have it goes up 5 for the independent variable, and it goes up 1 for the dependent variable, giving us this ratio. Now in order to be linear, the rate of change must remain, and the key word there is constant. You might look at those ratios and say, well, constant, this doesn't look like it stayed constant the same. But if we divide the 0.4 by 2, we'll get 0.2. We'd get the same thing here. And if we divide 1.2 by 6, we do get the same thing here. And if we divide 1 by 5, we get the same thing there. So the rate of change there is really 2/10 for all 4 of those points. So there is a constant rate of change. As a last example, let's look at what would happen if we graph y equals x squared and determine whether it's linear. Let's pick out points. If you get to pick any points you want, we've done this previously in another chapter. A lot of times it's easiest to pick out numbers small that are right around 0. We've got some negatives, some positives. So now to build this table, we need to take our -2 value for x, substitute it in for x. We would get that y equals -2 squared. Remember, if you square a negative number, that's actually a negative times a negative, and you'll get a positive. So in our table, the y value would be 4 there. If we substitute in next the -1 for x, -1 squared will give us 1. 0 squared would give us 0. 1 squared, or 1 times 1 is 1, and the 2 squared gives us 4. So now we're ready to graph it. If we take our point of -2, 4 and plot it, it shows up there on our graph. Please plot that with us. If we plot our next point of -1, 1, it would show up there. 0, 0 is there. 1, 1 is there. And 2, 4. And the last one already had come in. And I hope you guys look at this and know right away, this is not a straight line, therefore this would not be a linear relationship. So if you'd please write in, this is not a linear relationship, since the points, I put point, I should have an S on there, since the points do not fall in a straight line. Thanks, and we will see you tomorrow.